Hello everyone, welcome to Mathverse by Vishal. So in the previous videos, we have seen top 10 PYQs from the two chapters, complex numbers and also quadratic equations, right? Now in this video, I bring the top 10 PYQs from the chapter vector algebra, and this is a part 1. So let's see the first question for this video. Now this is a question from JEE Advanced 2025, last year advanced paper, and let's read it. Any 2 points m and n in the xy plane, let mn bar denotes the vector from m to n, and then 0 bar denotes 0 vector. So basically, they are giving you the definition of a vector. Let P, Q, R be three distinct points in the xy plane, and let S be the point inside the triangle PQR such that SP bar plus 5 into SQ bar plus 6 into SR bar is equals to 0 bar. Okay. So let's try to interpret from this first of all, then we'll go to the next part of this question. So since they said that PQR are three different points, let's take a triangle formed by the 3 points PQ and R. So this is P, Q, and R. Okay. Now here one more condition they have given here is SP bar plus 5 into SQ bar plus 6 into SR bar is equals to 0 bar. So this is a given condition. And moreover, what is a point S here? It is a point inside the triangle. So let's pick the point S randomly inside the triangle. So I'll assume it to be somewhere here, point S. Okay. And then let's continue the question. Let E and F be the midpoints of sides PR and QR. So E is the midpoint of PR. So let's put the point E here, and then F is the midpoint of QR. Okay. And then clearly we can join this E and F here like this. And then we have to find out the value of length of the line segment EF divided by length of line segment ES, which means you are simply supposed to calculate the ratio of these two lengths, right? So let's write it in the vectors form. We need to calculate the value of modulus of EF bar divided by modulus of ES bar. This is the ratio we are supposed to find out. Okay. So for that, first thing, if you observe the triangle here, we have E and F as the midpoints of these two sides of the triangle, right? Now we have the midpoint theorem of a triangle. What is the midpoint theorem of a triangle? The line segment joining midpoints of two sides will be parallel to the other side, and it will be exactly half times of the opposite side. So from here in this diagram, I can say that this EF will be parallel to PQ, and moreover the length of EF will be exactly is equals to half of PQ. This is what we know. And if I take the vector notations here, the directions, this will be EF bar and this will be PQ bar. So what is the thing that I can write from here? That EF bar is equals to half of PQ bar by using midpoint theorem. I hope it is clear. And then directly we get the magnitude of EF bar here. So magnitude of EF bar is equals to half of magnitude of PQ bar. Or else you can write it like this also, half of modulus of PQ bar is nothing but Q bar minus of P bar. So this is modulus of EF bar. Okay. So let's keep it aside. We'll use this in the last step. Okay. And then now next thing is we have to simplify the given equation that SP bar plus 5 times of SQ bar plus 6 times of SR bar is equals to 0 bar. Let's try to expand that and see what happens here. So SP bar is nothing but P bar minus S bar plus 5 into SQ bar is nothing but Q bar minus of S bar, and plus 6 into this will be R bar minus of S bar is equals to 0 bar. And here in this question, you can pick one of the vertices of the triangle as origin also. You can do it in that way also, absolutely no problem. And then let's simplify here. This is P bar plus 5 into Q bar plus 6 into R bar. And if you take all the remaining terms to the right side, which will give you 12 into S bar. 12 into S bar. And from there, finally, we get the vector S bar, which is equals to P bar plus 5 times of Q bar plus 6 times of r bar whole divided by 12. Okay. And what's the purpose of this finding S bar here? Because if you look at the required part in the denominator, we want modulus of ES bar. Okay. Now our next aim is that finding modulus of ES bar. The modulus of ES bar can be written as modulus of ES bar is nothing but S bar minus of E bar. We know that point very well. And which is equals to modulus of, now let's substitute this S bar, whatever we have got, P bar plus 5 times of Q bar plus 6 times of R bar whole divided by 12 minus of E bar. Now the point here is we need the vector position vector E bar. But if you look at this, E bar is nothing but the midpoint of the side PR, right? So which means I can write down E bar as simply P bar plus R bar divided by 2 because it is the midpoint of the side PR, right? That is why E bar is nothing but P bar plus R bar divided by 2. So let's take that and substitute it here. So in the place of E bar, I'm going to write it as P bar plus R bar whole divided by 2. And let's try to simplify here. Finally, we get modulus of ES bar is equals to, if you take the LCM properly here, then you're going to get something like this: P bar plus 5 into Q bar plus 6 into R bar and minus of 6 into P bar minus of 6 into R bar whole divided by 12. Let's take the constant 12 outside, so it will be 1 by 12 times of modulus. The main advantage here is 6R bar gets cancelled, right? Now the remaining part is only what? 5 Q bar minus of 5 P bar. And if you take 5 common here, I can write this as 5 by 12 times modulus of Q bar minus of P bar. Okay. Now this is the main advantage of writing modulus of ES bar in this way. Because what we need is a ratio of these two, right? So finally we get modulus of EF bar divided by modulus of ES bar is equals to numerator is, just now we have got half of modulus of Q bar minus P bar and divided by modulus of ES bar is 5 by 12 times of modulus of Q bar minus of P bar. The main advantage is this modulus part will be cancelled out and the remaining part is only 6 divided by 5 if you do the remaining calculation. Okay. So this is the value we are supposed to find out, which is equals to 655. Okay. So it is not a difficult question. The only thing is proper diagram and the midpoint theorem you have to recall to solve this question. And as I told, this is a question from last year JEE Advanced. Okay. Let's take the second question for this video. And this is also a question from last year JEE Advanced again. Okay. So consider the vectors x bar is equals to I cap plus 2j cap plus 3k cap. Similarly, y bar and also z bar also given. And they said that for two distinct positive real numbers, alpha and beta. So let's keep this in mind that alpha comma beta are distinct here because we are going to need this in the final step. Alpha comma beta distinct positive real numbers, and then define capital X bar, capital Y bar, capital Z bar. So clearly you can notice that this capital X, capital Y, capital Z bar are represented in terms of linear combination of small x, small y, small z. And finally, what they are saying is the vectors capital X, capital Y, capital Z are lying in a plane. Okay. So again, this is also not a difficult question. The only thing is the proper property is required. If you remember the formula, this question can be done in less than 2 minutes. Okay. So let's try to recall the concepts related to this. First thing, it's mentioned that this capital X bar, capital Y bar, capital Z bar lies in a plane. So if three vectors are lying in a plane, we say that the three vectors are coplanar vectors. They are coplanar vectors. So whenever we have three coplanar vectors, directly we can say the box of that is equals to 0. The box of X bar, Y bar, Z bar should be is equals to 0. But the thing is here this capital X, capital Y, capital Z are represented as a linear combination of small x, small y, small z, right? So let's try to properly write down these values as per the given question. capital X bar is equals to alpha times of small x bar, alpha times of small x bar plus beta times of small y bar minus of z bar. And then capital Y bar is equals to minus x bar plus alpha into y bar plus beta into z bar. Similarly, this capital Z bar is equals to beta into x bar, small x bar, minus of y bar plus alpha into z bar. Okay. Now, the property we have to recall here is whenever we have three vectors as a linear combination of three other non-coplanar vectors, what we know the property is box of capital X, capital Y, capital Z should be is equals to first thing you have to write down the determinant of all the coefficients. Okay, all the coefficients of small x, small y, small z. So write down all the coefficients one by one. That is alpha, beta, minus one, and then minus one, alpha, beta, and then beta, minus one, alpha. And this multiplied by the box of small x, small y, small z. That is the vectors as the coefficients in this capital X, capital Y, capital Z. So this is our property. Whenever we have three vectors as a linear combination of three other non-coplanar vectors, we can directly write down the box product of these vectors as is equals to det of, you write down all the coefficients one by one, put them in order and write down all the coefficients in the determinant and multiplied by the box of x bar, y bar, z bar, that is small x, small y, and small z. Okay. So for this, we need the value of what? Box product here of small x, small y, small z. So let's try to calculate that here. So box of small x bar, small y bar, and small z bar. So how do we find out box product of any three vectors? We just find out the determinant value, right? So let's do that. Determinant of, so if you look at the question, small x is given as I plus 2j plus 3k, nothing but that of 1, 2, 3, and then 2, 3, 1, and then 3, 1, 2, 3, 1, and 2. Now, let's try to expand the determinant here and try to find out this value. So this is equals to 1 into 6 minus of 1 minus 2 into 4 minus 3 and plus 3 into 2 minus of 9. So which will be 5 minus of 2 and minus of 21. Okay, so which is clearly not is equals to 0. Okay, we just need to make sure this is not is equals to 0 or not. Okay? Because when you write this value here, we are trying to make sure this box of capital X, capital Y, capital Z is equals to 0 here, right? And if I put that value here, finally we get det of alpha, beta. I'm sorry, this, okay, right. So this is alpha, beta, minus 1, alpha, beta, and beta minus 1 alpha. Okay. And moreover, even if you calculate the previous small x, small y, small z box product also, what you are going to get is minus of 80. So I'll tell you the reason for finding that. So this is det of this multiplied by minus 18 is equals to 0. So clearly this is a non-zero value. You can cancel out. And finally, the leftover part is only what? Det of this one. So let's try to expand this determinant. Alpha into alpha square plus beta minus of beta into minus alpha minus beta square and then minus 1 into 1 minus of alpha beta is equals to 0. So this is the remaining condition for this determinant, that is box of capital X, capital Y, capital Z is equals to 0. Okay. And I'm trying to highlight this formula that we have used here. And moreover, I found out actually in this question, you might think that why exactly do we need this box of small x, small y, small z? Anyhow, it is going to be cancelled out when you equate it to 0. So don't think like that because we have to ensure that box of small x, small y, small z is always a non-zero value. That is, indirectly, we are making sure that these three vectors are non-coplanar vectors. Non-coplanar vectors. Only then this will be true here. Okay. And now let's see the remaining calculation part. If you expand this properly, you're going to get something like this: alpha q plus beta q, and then minus 1 is also there, and plus alpha beta, totally plus 3 alpha beta is equals to 0. Okay. And I can also simplify this further. And this is the main part here, that is alpha q plus beta q. Now I'm going to write this minus 1 as plus minus 1 whole cube is equals to, if I take that 3 alpha beta to the right side, I can write this as 3 into alpha into beta into minus 1. Okay. So finally, it is looking like a known formula here. So what's our known formula here? So let's try to add that one also. So what's our property when we have AQ plus BQ plus CQ is equals to 3ABC? Two conclusions can come. That is, either A plus B plus C is equals to 0, or also A is equals to B is equals to C. Two conditions, two cases are possible. So if you observe this result, whatever we have got, it is exactly looking like this formula here. AQ plus BQ plus CQ is equals to 3ABC. Now let's try to take the conditions here. First condition is what? Alpha plus beta plus minus 1, because A is alpha, B is beta, C is minus 1. So A plus B plus C is equals to 0. In this case, we get alpha plus beta is equals to 1. And moreover, one more case is also possible, that is alpha is equals to beta is equals to minus 1, because we have one more case also, A is equals to B is equal to C. Okay. But if you read the question, I told you, right, the important part we have to keep in mind that alpha comma beta distinct positive real numbers. So clearly here in the second case, alpha comma beta are not distinct, right? So which means this case is not valid. So the only possible case here is alpha plus beta is equals to 1. Okay. And finally, if you look at the required part, we have to find out alpha plus beta minus of 3. So once we know the value of alpha plus beta, you can take it and substitute it here to get the final answer as minus 2. Okay. So as I told, question is not difficult. The only thing is you have to recall this formula. Okay. Let's see the next question. This is a question from JEE Advanced 2023. And this is one of the questions which might be asked in the upcoming JEE main session also, because these types of questions are frequently asked in from vector algebra. Let's see the question. The position vectors of 4 points P, Q, R, S are given directly to you as A bar, B bar, C bar, and D bar. And which of the following statements is true? So let's see option by option. So the first option, they are saying that the points P, Q, R, S are not coplanar. Okay. But what do we know about coplanarity of 4 points? Let's mention the property here. If the 4 points P, Q, R, S are coplanar, then the box product of PQ bar, PR bar, and PS bar should be is equals to 0. So when we have 4 points A, B, C, D which are coplanar, then the box product AB bar, AC bar, and AD bar should be is equals to 0, because they become coplanar vectors. And again, once again, you know how to find out the vectors PQ bar and everything here. Okay, so PQ bar here is nothing but OQ bar minus of OP bar. And clearly the point Q is directly given to you, that is 3i cap plus 6j cap and plus 3k cap. Minus of OP bar is also given to you, I cap plus 2j cap minus of 5k cap. And if you do the proper calculation, you get the vector PQ bar as 2i cap plus 4j cap and plus 8k cap. So you have the vector PQ bar. So in the similar way, you will also be able to find out the two other vectors, PR bar and also PS bar. Okay, so PR bar is what? OR bar minus of OP bar. So I'm leaving the calculation part to you, because directly you can find out, right? So PR bar and PS bar you try to find out, and then you try to take these three values, that is these three vectors PQ, PR, and PS, and try to apply the box product here. So what is our conclusion? If the box of PQ, PR and PS is equals to 0, in that case we can say that the 4 points PQRS are coplanar points. They will be coplanar. But at the same time, if PQ, PR, PS box product is not is equals to 0, then they are not coplanar. Then they are non-coplanar vectors. Okay. And I'm leaving the calculation part for you. Directly you know how to calculate the box product of three vectors, right? So let's leave the calculation part for you. And then in that way, you try to check for the option A. Okay. Now we'll try to check the option D next. Okay, because that is somewhat easy. Here, option D here is saying that the square of magnitude of the vector B cross D, that is modulus of B cross D whole square, is equals to 95. But once again, you know how to find out B cross D here, right? Clearly, B bar is there. D bar is also there in the question itself. This is determinant of, we know how to find out cross product of two vectors, I cap, J cap, K cap, and then B bar is given by 363 and D bar is given by 211. And once again, I'm leaving the calculation part to you because you know how to expand the determinant and you know how to find out the vector B cross D. And for that, you try to find out the magnitude and check whether it is equals to 95 or not. Okay, so this is also not a difficult thing to do. So you will check the option D by yourself. And then I will show you the process of checking option B and option C. But before that, you try to read the option B first. D plus 2D divided by 3 is the position vector of a point which divides PR internally in the ratio 5 is to 4. Okay, so which means suppose if I have the line or vector PR in this way, so let's take a P are in this way. Now what they are saying is B plus 2D divided by 3 is the position vector of a point which divides PR internally in the ratio. So there are two ways of checking this option. One thing is you can find out the point which divides PR in the ratio internally 5 is to 4 and check whether that is equals to B plus 2D divided by 3 or not. Okay. Otherwise, you can start the question like this also, that you can assume the point, let B plus 2D by 3, B plus 2D by 3 divide PR in the ratio some lambda is to 1. Okay, we know how to assume a unknown ratio and then substitute the section formula here, right? So let's try to do in this method and let this vector be some A bar, otherwise some L bar. I will take it as some L bar. So I'm assuming that L bar is dividing this PR in the ratio lambda is to 1. And we know how to apply the section formula here. So L bar should be is equals to lambda into R bar plus 1 into P bar whole divided by lambda plus 1. Okay. And then finally, L bar is nothing but B bar plus 2D bar divided by 3, which is equals to lambda times of R bar. We know what is R bar from the question here. R bar is a position vector of R bar is the point representing C bar here. So you can write down that value, that is 17 by 5 I cap plus 16 by 5 J cap, 16 by 5 J cap and plus 7 K cap, 7 K cap plus P bar. So we know what is P bar also here. P bar is I plus 2J minus 5K, I plus 2J minus 5K whole divided by lambda plus 1. Now clearly you can solve this equation on both the sides, right? So what we can do is left hand side we have B plus 2D divided by 3 is equals to right hand side. If you try to separate the terms, I cap multiplied by, this will be 17 lambda divided by 5 plus 1 divided by lambda plus 1 and then plus J cap multiplied by, this will be 16 lambda by 5 plus 2 divided by lambda plus 1. Similarly, if you separate k cap from the right hand side, you get 7 lambda minus of 5 whole divided by lambda plus 1. And left hand side also, we can substitute the values of b and also d here, right? So let's do that. Left hand side, b is given as 3i plus 6j plus 3k plus 2 times of d bar. D bar is also given to us in the question, 2i cap plus j cap plus k cap whole divided by 3. So if you calculate this one, this will be 4 plus 3 is 7. 7i cap plus 8j cap plus 5k cap whole divided by 3. Whole divided by 3. Okay. Now you can just equate these two, right? So let me take this value here, whatever we have got on the right hand side. Now we got that these two vectors should be same here. Now you can directly equate the coefficient side. So you get three conditions here. 7 by 3 is equals to, from here you get 17 lambda plus 5 divided by 5 times of lambda plus on equating the coefficients of I cap here. And you can cross multiply here, which will give you 35 lambda plus 35 is equals to 51 lambda plus 15. And you can do the remaining calculation here. That is 16 lambda is equals to 35 minus of 15, which will be 20. So finally, lambda is equals to 5 divided by 4. So we are getting the ratio as lambda is equals to 5 by 4 here. But let's see the option B again. B plus 2D by 3 is the position vector of a point which divides PR internally in the ratio of 5 is to 4. So we have taken that point is dividing in the PR in the ratio lambda is to 1. And finally, we got the value of lambda as 5 by 4. And our ratio lambda is to 1 becomes 5 is to 4. Okay? And then don't directly think that this is the correct answer, even though you got lambda is equals to 5 by 4 here, because after getting lambda is equals to 5 by 4, you need to ensure that the coefficients of j cap and k cap are also same. That's the most important part. This is the part where many of you will make a mistake. Directly in a hurry, you get value of lambda as 5 by 4. So you'll mark the second option as internally divided. And then don't do that. You need to definitely verify. So as I told, what will you do? You will equate the j cap coefficient, that is 8 by 3 is equals to 16 lambda plus 10 divided by 5 times of lambda 1. Similarly, you will equate the k cap coefficients. 5 by 3 is equals to, this will be 7 lambda minus 5 divided by lambda plus 1. So what is the concept that I told you? Take this value of lambda is equals to 5 by 4. Substitute in both these equations, and then definitely you have to verify whether this value of lambda is satisfying the two equations or not. Only then the system is going to be consistent, or only then we can say that the actual ratio is 5 is to 4 internally dividing. Otherwise, you cannot say that. Okay? Be very careful. Let's take the next question. And this is a question from the very recent JEE Mains 2026 January session. And once again, this kind of questions are frequently asked in the JEE Mains. Okay, you can look at the PYQ questions. You will find lot of questions of such model. So let's try to see how to approach these kind of questions. Okay. Let C bar and D bar be two vectors such that modulus of C plus D is equals to square root of 29. And then one vector equation is given. So let's write down whatever is given. C bar cross 2i plus 3j plus 4k cap now is equals to 2y plus 3j plus 4k multiple cross product with d bar, and I will take that term to the left hand side and write down directly minus of 2y plus 3j plus 4k cross product with d bar is equals to 0 bar. But I will change the order of the vectors in the second term, that is c bar cross 2y plus 3j plus 4k plus d bar cross 2y plus 3j plus 4k is equals to 0 bar. When you know that when you interchange the vectors in the vector product, you put a minus sign before that. And clearly on the right hand side, we have a common vector. So take it common on the right side. And then the remaining part will be C bar plus D bar cross product with 2 I cap plus 3j cap plus 4k cap is equals to 0 bar. So this is the main advantage of doing this process. Clearly you get the cross product of two vectors as 0. So whenever the cross product of two vectors is 0, we know that the two vectors should be parallel. So let's mention that condition that C bar plus D bar should be definitely parallel to 2i cap plus 3j cap plus 4k cap. So if there are two vectors which are parallel to each other, we know that one of them can be expressed as a scalar multiple of the other. So which means I can write down this one as C bar plus D bar is equals to lambda times of 2y cap plus 3j cap plus 4k cap. Okay. Now let's take it as equation number 1 and keep it aside because we are going to need this in the next part of the question. Now let's continue the question. If lambda 1 and lambda 2, where lambda 1 greater than lambda 2, are the possible values of c plus d dot minus 7 plus I plus 2j plus 3k. Okay, so which means first of all we need the value of this c bar plus d bar vector. But if you observe carefully, there is one more condition given in the question, which is modulus of c plus d is equals to square root of 29. So I'm going to apply modulus on both sides for the equation 1 from which I can get the value of lambda here. Okay, so modulus of c plus d is equals to modulus of lambda multiplied by modulus of 2y plus 3j plus 4k cap. So finally, since already this value is given as square root of 29, which is equals to modulus of lambda multiplied by this is square root of 4 plus 9 plus 16, which will be exactly is equal to square root of 29, so that I can cancel these two out. And finally, what we get is mod lambda is equals to 1 implies lambda is equals to plus or minus 1. Okay. And here, don't take these values as lambda 1 comma lambda 2 because lambda 1 comma lambda 2 are the values of this dot product here. So you have to be very careful. Don't commit this mistake. So first thing, we have to find out the dot product of c plus d and the vector minus 7i plus 2j plus 3k here. Okay. Now for that, I will take this value of c plus d. And from equation 1, what is this c bar plus d bar here? C bar plus d bar is equals to lambda value is plus or minus 1 plus or minus times 1 times of this is 2i plus 3j plus 4k. You can take this vector c plus d and substitute in this one. So finally, what do we get here? Plus or minus of 2y cap plus 3j cap plus 4k cap. And then dot product with minus 7i cap plus 2j cap plus 3k cap. So which is equals to plus or minus of, when you take the dot product, what do we get here? Minus 14 plus 6 plus 12. Okay. And if you do the calculation here, you get this as plus or minus 4, right? Plus or minus 4. Okay. Now this is what they are saying. The values of lambda 1 comma lambda 2 are. Okay. Moreover, they mentioned that lambda 1 is greater than lambda 2, which means from here you must take lambda 1 is equals to plus 4 and you must take lambda 2 is equals to minus 4 here. Okay. And now we have got the values of lambda 1 comma lambda 2. Now the question is not over yet because we have to find out this value here, k value. And for that they gave one more equation. So let's write down what is given there. It is given as k square x square plus k square minus of 5k plus lambda 1 times of x into y plus 3k plus lambda 2 by 2 multiplied by y square minus 8x plus 12y plus lambda 2 is equals to 0. And they are saying that this equation here is representing a circle. Okay? This equation here is representing a circle. And then we have to find out the value of k. Okay. Now this is not a difficult part because you know the values of lambda 1, lambda 2. You can substitute first where k square x square plus this will be k square minus of 5k plus lambda 1 value is 4. So 4 times of xy plus 3k plus lambda 2 is minus 4. So if you substitute that value here, you get it as my 3k minus 2 and then into y square and minus of 8x plus 12y plus lambda 2. Again, lambda 2 is minus 4 is equals to 0. Now, this is a second degree equation, right? So, but if this is representing a circle, two conditions must be satisfied that this coefficient of x square must be is equals to coefficient of y square. So, from which we get k square is equals to 3k minus 2, k square minus 3k plus 2 is equals to 0 implies k is equals to 1 comma 2. And also simultaneously it has to satisfy the condition that coefficient of x into y is also is equals to 0. So if you make this coefficient of xy to 0, we get k is equals to 1 comma 4. Okay, and then clearly you must take only the common solution here. So for these two values, for these two cases, the common solution is only k is equals to 1. So which means the value of k here should be is equals to 1. So you can take that value and substitute in the equation back to get the circle equation. Okay, if you put k is equal to 1, what do we get? X square plus y square minus 8x plus 12y minus of 4 is equals to 0. Okay. And in this case, the required question itself is k value. So directly k is equals to 1. Okay. And sometimes it's better to verify whether this is representing a real circle or not. So let's do that. R is equals to square root of this will be 4 square 16 plus 6 square and plus 4. So clearly you are getting square root of a positive value, no problem. Okay, because sometimes what might happen is when when you try to calculate the radius, it might turn out to be square root of a negative value. So in that case, there is no real circle possible. In that case, we can say that for no value of k, this will represent a real circle. Okay, you have to be careful with that thing also here. Right? Let's take the last question for this video. Now, this is also a question from the very recent JEE Mains 2026 January session. Now, once again, I take this question for only one reason because this kind of questions are being repeated many times. Okay? That is, the angle between two vectors is given as acute and obtuse. So, we'll try to see how to approach with these questions. The first thing, there are two vectors given, a bar and b bar, and moreover, lambda is greater than 0. Let's keep that in mind. And then they said that the two vectors have an obtuse angle between them. Okay. If the vector a bar make an obtuse angle with the vector b bar. Okay. First, let's try to simplify that. So what do we know? If angle between a bar and b bar is obtuse, then we can say that a bar dot b bar should be less than 0. Okay, this is our property. Don't forget that. If it is acute, a dot b will be greater than 0. If it is obtuse, a dot b will be less than 0. And if it is a right angle, a dot b will be is equals to 0. Okay. So first, let us try to find out a dot b here because already a bar is given to you in the question. B bar is also given to you in the question. Let's do the dot product directly. Okay. And then you get this as a dot b, which is equals to minus of root 2 into lambda square when you multiply the coefficients of I, and then minus of 4 root 2, and then next one is plus 4 root 2 into lambda plus 4 root 2 into lambda, which is less than 0. Okay, so which is clearly forming a quadratic equation. So if you cancel out this minus root 2 in the inequality, you get lambda square minus of 4 lambda and plus 4 is greater than 0 because you are cancelling out a negative number, right? You have to reverse the inequality here. And then lambda square minus 4 lambda plus 4 is nothing but directly lambda minus 2 whole square greater than 0. So clearly lambda minus 2 whole square is a perfect square. And if that perfect square is always strictly greater than 0, the only thing is lambda cannot be is equals to 2. But for all the remaining values, it is obviously correct. So in the first case, I can say that lambda belongs to complete real numbers minus set containing 2. Because when you put lambda is equals to 2, it will be 0 greater than 0. It's not correct, right? And then let's take the next part of the question here. The angle between theta make an obtuse angle with the vector b bar and an angle theta where theta belongs to uh, pi by 6 to pi by 2. Let's mention that theta belongs to pi by 6 to pi by 2 with positive z axis. So they are saying that the vector a bar is making an angle theta with the z axis. But what is z axis actually? Nothing but k cap, right? So first of all, let's try to find out this cos theta value. So we know that cos theta will be is equals to a bar dot k cap divided by modulus of a into modulus of k. This is the formula to we have to calculate the angle between two vectors, right? A dot b divided by modulus of a into modulus of b here. Okay. And then here they said that theta belongs to pi by 6 to pi by 2. We'll put that condition later, but let's try to calculate a dot k here. So what is a dot k? Dot product of a bar with k cap will give you only lambda and divided by, let's calculate modulus of lambda also here. Modulus of lambda will be square root of 2 plus 1, 3 plus lambda square, which will give you lambda square plus 3. And modulus of k cap is directly 1. So which means we get the value of cos theta as lambda divided by square root of lambda square plus 3. But clearly, given that theta belongs to pi by 6 to pi by 2, we can find out the range of cos theta here. So cos 30 will be root 3 divided by 2, which is greater than cos theta, greater than cos pi by 2 is 0. So which means this value cos theta here should belong to 0 to root 3 by 2. We have to reverse the inequality sign, right? Because cos theta is a decreasing function in the first quadrant. And then we have the value of cos theta. Take this value of cos theta, substitute it here, from which we can get 0 less than cos theta is lambda divided by square root of lambda square plus 3 is less than square root of 3 divided by 2. And clearly the denominator here is a positive value. You can cross multiply. So 0 less than lambda less than root 3 by 2 times of square root of lambda square plus 3. And then by taking the left side part, you get lambda strictly greater than 0. And then by taking the right side part here on cross multiplying and squaring, you get 2 lambda square is less than 3 lambda, 3 into lambda square plus 3. And you can calculate the remaining part. This will be 4 lambda square less than 3 lambda square plus 9. So finally we get lambda square less than 9, which means lambda belongs to minus 3 to 3. You know how to solve the wavy curve, right? Lambda belongs to minus 3 to 3. But we must take the common part of these two here. So upon taking the common part of these two, you get lambda belongs to open 0 to 3. Lambda belongs to open 0 to 3. But keep in mind, already we got one more condition here as capital R minus set containing 2. And if you take the common part of this and this, you get finally the value of lambda. Lambda belongs to 0 to 3, but you can't include the value of 2 here. That is why the range of lambda is this. Okay. And let's see the required part, what they're asking. If the set of all values, possible values of lambda is alpha comma beta minus set containing gamma, we have to find out the value of alpha plus beta plus gamma. So clearly you can notice that alpha is 0, beta is 3, gamma is 2, and hence you can find out the value of this one. Okay. And this is also not a difficult question. The only thing is the process here. As I told, we should know how to apply the condition when we know the angle between two vectors as obtuse or acute. Okay, right. So we'll discuss the remaining questions in the next part. Okay, thank you.